So in this video, we'll look at the meaning of local maximum and local minimum values of the function f of x, and we'll look at a couple of exercises on how to find them. And please look at the current picture here. You see right at this point. Local maximum means we only check out the values around this point. So local maximum means we only check out the values around this point, which means that around here, you can look at what you have here. You see, right around here, if you zoom out a little bit, this point is clearly the point that you can achieve the highest values among all the points near x1. And in that case, we call such a point local maximum. It is definitely not the same as the concept of absolute maximum. Absolute maximum means depending on the value of x you look at, you really have to check out the only maximal value among all the values x. They are not the same concept. And similarly, this one is a local minimum because right around here, you see, right around here, the fact is that this point is really the lowest point on this line. And I hope you can really think about the meaning of local max and min, which is totally not the same as the meaning of absolute maximum and absolute minimum. Because you see, if this line is actually like this, and you see all these points, we cannot say they are local maximum because they are really not the highest value you can achieve in any local neighborhood at any point, right? But all these points you see has achieved a higher value than this local maximum. And anyway, it doesn't change the fact that this point x1 is actually a local maximum because for local maximum, we only care about the neighborhood. As long as around this point, for the value around this point, these values are all lower than the value you can achieve at x equals x1, we'll call it a local maximum. And local minimum has the same meaning. So now, mathematically, let's try to think about how we can find these local maximum point, local maximum values if you're given a function. Please look at the behavior around this point. You see, before approaching these local maximum points, you are actually traveling upward until you reach this point, which is the maximum, and then you change the direction and it becomes minimum, right? So it means what? And please think about this fact. The fact is that when you're going up, the f prime is the slope value of the tangent line. And for any increasing line, increasing tangent, the f prime is actually positive. And similarly, when you are going downward, which means the arrow is going downward, the f prime is actually negative. So it means what? It means what? It means if x0 is a local maximum, we actually expect that value slightly smaller than x0, the f prime is positive like this picture. And for values that are slightly bigger than x0, we expect the f prime to be negative, right? So it means if you're able to locate such points, if f prime changes from positive to negative, then we expect that this point, then x0 is actually a local maximum point. And for the local maximum value, of course, you can evaluate it based on the function f of x at this point. And similarly, for the local minimum, the situation is completely opposite to what you see in the case of local maximum. If the point x1 is a local minimum, then the f prime, if the f prime changes from negative to positive, then we call this point is a local minimum point. And this test that we use, which is about detecting whether the derivative, the first derivative, is changing sign. To get the point which is either local maximum or local max minimum, This method is called the first derivative test. And first derivative test means you need to find the local maximum and local minimum based on the f prime, and you need to detect whether f prime is changing sign at a particular point. And let's look at some examples. So please look at the current example now. The function f is given. You are required to find all the local maximum and local minimum points and values. And based on what we said, the first derivative test, we need to find the f prime first. The derivative f prime is the same as 4x cubed minus 4x. And to detect whether the f prime changes sign, my advice for you is that to set it 0, set f prime 0, and solve for x. Let's see why this is important. Essentially, you are trying to find the critical numbers, right? So let's make it 0 now. We need to solve it. So we can pull out the common factor for x. And the second factor now is x squared minus 1. And please solve it yourself. And x can be 0, or x squared minus 1 is 0, but x squared minus 1 is 0 means x is either plus 1 or minus 1. So you see, all together, you actually have 3 critical numbers altogether, which is minus 1, 0, and positive 1. And to do the first derivative test, you can actually look at the sign table. Please look at the sign table now. The 3 points of the critical numbers are marked on the x line, the number line for the x value. And what you need to do on this table is that you need to randomly choose some points in each interval. By interval, I mean, please look at the problem now. The whole x-axis is cut off into 4 different parts, and we can call it 4 intervals now. And for each of these interval, you need to randomly pick one value, and the value itself doesn't matter because we just need to check the sign of f prime. The sign of f prime does not rely on the point you choose in each interval. It means that if you look at the same interval, no matter which x value you choose, it's not going to affect the sign of f prime in that particular interval. So let's do the calculation now. For example, for the left interval. For the left interval here, the value that I can choose is maybe minus 2. I mean, because minus 2 is something smaller than minus 1. Basically, any value less than minus 1 would do the job, but I choose minus 2 as a particular example. So for the first interval, we evaluate the f prime at minus 2 to get minus 24. And as I said before, the numerical value doesn't matter to us. The only thing that matters is we note that it's a negative number. It's a negative number. So I put a negative sign here. And how about the second interval? The second interval, I can actually choose maybe minus 0.5. And if you evaluate the f prime at this point, it's actually a positive number. It's positive 1.5. And the exact value doesn't matter to us. We only note that the sign is not changed. I mean, the sign is not changed no matter which value you pick between the interval minus 1 to 0. Now let's look at the next interval. The next interval is between 0 and 1. And between 0 and 1, I can pick something in the middle, let's say 0.5. So you can do similar evaluation. So you see this third point, you will get that the f prime is minus 1.5. So it means I add a minus sign here because the sign is negative for the third interval. For the last interval, all the points bigger than 1 will do the job. So I just randomly choose maybe 2 in the last interval. So f prime of 2 is going to be 24, which is of course positive. So I put the sign here again. You see in this particular problem, I obtained the sign table here, which is the first derivative test. And to tell me the local minimum values and the local maximum values, you need to look at the sign change here for the f prime. You see, it's a good habit to put the arrow to represent the sign of f prime. I mean, if f prime is positive, if f prime is positive, it means that the tangent direction is going up. And if f prime is negative, the tangent direction is going down. So I'm just adding the arrow to this picture, you see? And now, let's focus on this picture. So on this picture, as you can see, at the critical number -1, you see there's a sign change of f prime from negative to positive. So in terms of direction, the tangent direction is from negative to positive, right? So it means we actually have a local minimum at this point. Also, there's another local minimum here, which is this point, you see. When x is 1, it is also a local minimum because you see the key is that you are going down first, then you go up. So it's a local minimum also. And there's a local maximum, which is based on the middle point 0, because around 0, what you can see is you go up first, then you go down, right? So which means we have only one local maximum and two local minimum points. And to find the corresponding values of them is actually quite straightforward. Once we know all the local maximum, local minimum points, you just need to evaluate the f at all these points. So for example, f of -1, you can evaluate it first, and you can also evaluate it at the point x equals +1, right? And you can do this calculation, and actually the answer is quite easy. Both of the values are actually 4, both. So these are the local minimum values, and it's just coincidental that both values are the same 4. And also, we have only one local maximum point, which is at the point x equals 0. And if you evaluate it at the function f, it's going to be 5. So these are all the values we have for the local minimum point and local maximum points.